It's one of those, depending on if he wants it above this surface or above this surface, which is 10 meters below. Not that big a deal, just pay attention to what he asks for. So that's how you do your max height. That's done. Now the part that's a little bit harder is V impact. What is the velocity of the object when it strikes this lower surface down here? Well, it's not that hard when you break it up into little pieces. So what I want to have you focus on is this right here, this area, right where the object crosses the vertical where it took off. So, like I said before, if there were no cliff, if this surface extended this way, it would hit right here. And one thing that we know about when things hit at an identical surface at height that it originally took off from, it actually leaves at V impact. So if it hit this flat surface right here, it would hit at 20 meters per second at 30 degrees, just this way instead of this way. It would take off at 20 meters per second at 30, land at 20 meters per second at 30. But it would be 30 degrees this way. See what I'm saying? Because it mirrors what happens over here. So let's take a look at what's happening inside this circle right as it crosses this flat line. And I have this going on for you right here. So keep in mind, just to clarify, that this right here, this dotted line, is this solid line, and this dashed line is still this dashed line right here. So if you can wrap your head around that, then we'll continue. So, like I said, it got shot at 20 meters per second at 30 degrees, which means it's impacting this imaginary surface, which doesn't exist because of the cliff. It's impacting at 20 meters per second at 30 degrees, just like that. Now, by just the rules of geometry, that means that it's 30 degrees over here, and it's 20 meters per second over here. Same thing. I'm talking about the instant that it crosses this line. So what you can do now is draw the same exact triangle that you had before, which is this one right here, but you draw it in reverse. So this is still 20 meters per second. Your x component is still 17.32, and your y component is still 10. But now instead of a y component up, it's a y component down. And the x component is still to the right. And this is your 30 degrees right here. That's sort of the hard part that you just need to get used to doing, because that's how you do it. So, knowing that, you can set up another Big Ten equation chart. So it's still going to be delta y, because we're talking about up and down. And you have your VO, VF, A, and T. And start filling in what you know. Well, your delta y, you actually know, because the height of the cliff is 10 meters. See this right here? Now we're dealing with the second half of the problem. First we dealt with above the dotted line, above the imaginary surface. Now we're dealing with below. So your delta y, the distance that it has left to travel, is 10. So you put that in as 10. Your VO is your initial velocity in the y direction, which we figured out is right here. This is this 10. So you're like this. Your final velocity, you don't know. You definitely don't know that. Your acceleration is your acceleration due to gravity, which is 9.8. And in this case, you leave it a positive 9.8, because after that object comes down and reaches this surface, gravity is helping it speed up. So gravity is acting on the velocity of the object in a positive way now. Rather than slowing it down, it's speeding it up, because now it's going down. So you leave that as a positive 9.8. In the t, the time it takes to happen, you don't know. So you start doing your equation again, which is delta y equals VOT plus 1/2 AT squared. Start plugging in your values, but then you realize, okay, I have a delta y, 10 equals VO, okay, I don't have a t, plus 1/2 A, 9.8 t squared. Well, you're only missing one variable, and that's a t. And the problem is, if you use the other equation that you use, which is delta V equals AT, which is just VF minus VO equals AT, you realize that you don't have VF, you have VO, you have A, but you don't have T. So this equation is of no use to you. You're missing a VF and you're missing a T. You have two unknowns with only one equation. So if you take a closer look at this equation over here, that can be rewritten as 0 equals minus 10. You bring the 10 over, the positive 10 to the other side by subtracting it, so you have a minus 10, plus 10t plus 1/2 9.8 t squared, which is a quadratic. You have one variable, but it steps down in steps of 1 in the exponent. You have a t squared, you have a t, and you have a term that doesn't have a t in it at all. So what you do now is you set that up in the quadratic formula. And as a little refresher, the quadratic formula has three variables, a, b, and c. A is the coefficient associated with t squared, which in this case is 1/2 9.8, which is just going to be 4.9. You just solve 1/2 9.8 and it's 4.9. So A is 4.9. B is the coefficient associated with the t term, which in this case is 10. And C is the coefficient associated with no t term, which in this case is minus 10. So you plug that into the quadratic formula, which I will tell you, in this case, you want to solve for t. So you say t equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm not going to solve that for you because you can plug in the values yourself and do that. But I've solved it on my own, and what you end up with are two t values. That's what you get in a quadratic. You get two values because of this plus or minus. Well, the two values that you get are t equals minus 2.77 seconds and t equals 0.73 seconds. A negative time doesn't make any sense, so you don't use that one. You use this right here. T equals 0.073 seconds. Now that you know that, you can plug that back into your you plug that back into this equation, this delta V equals AT. Because if you plug it into your delta Y equals VOT plus 1/2 AT squared, that's not going to give you anything. All you're going to do is prove that you did it right. If you plug 0.073 back into here, you're just going to get 10 equals 10, which you don't want. You want to find your final velocity, VF. So you say delta V equals AT, which is VF minus VO equals AT. Now that you know T, you can plug that into here, which is what you want, and you end up getting VF minus VO, which is 10, from up here, see? VF equals A, which is your 9.8, which you get from up here, and your new value that you just figured out, T, 0.73. And what you end up finding is VF equals 17.15. Now let's recap what we just figured out. We were dealing only with the y direction, and we determined that it impacts in the y direction down here at 17.15 meters per second. So that impacts 17.15 meters per second, and that's only in the y direction.